Dear students, in the last session, we have seen how to obtain the percentage of all possible observations of a normally distributed random variable that lie within a specified range. First, by expressing the range in Z terms, converting X into Z and determining the corresponding area under the standard normal curve. So, X between A and B is equal to Z between these two intervals, that is A minus mu by sigma, B minus mu by sigma. So the percentage of X lying between A and B is same as percentage of Z lying between, so Z1 and Z2, X1, X2. Now, we know how to convert X into Z simply by subtracting the mean and dividing it with a sigma. Now we have to see how to determine the area under the standard normal curve. How to find out the area under the standard normal curve. And before explaining how to find out the area under the standard normal curve, we first consider the basic properties of the standard normal curve. And remember this, the standard normal curve is derived from the normal curve of a normally distributed random variable. So naturally the properties of the standard normal curve is derived from the properties of the normal curve itself. We know that the normal curve is bell-shaped. So standard normal curve is also bell-shaped. The normal curve is centered around mu. So the standard normal curve is also centered around mu, but it is 0 now. Third, a normal curve is close to x-axis beyond what is known as mu plus 3 sigma and mu minus 3 sigma. So naturally, a standard normal curve is close to 0 beyond plus 3 and minus 3. Close to 0 beyond plus 3 and minus 3. That is, most of the observations of the standard normal distribution lie between minus 3 and plus 3, as most of the observations of the normal distribution lie between mu plus 3 sigma and mu minus 3 sigma. And we know that a normal distribution, a normal curve is symmetric. So naturally standard normal curve is also symmetric. But here it is symmetric around mu, here it is symmetric around 0. Also, the area under the normal curve is 1, so area under the standard normal curve is also 1, and both are bell-shaped. Both are bell-shaped. So, let me repeat, area under the standard normal curve is 1. Standard normal curve extends indefinitely in both directions, approaching to the x-axis, but never touching the x-axis. It is symmetric around 0. Symmetric means the the area to the left of 0 is the mirror image of the area to the right, and almost all the observations lie between -3 and +3. Now let us see how to use the standard normal table to find out the area under the standard normal distribution. And remember this, we can calculate the area under the normal distribution between any 2 points by calculating the area between any 2 points under the standard normal distribution. So for finding out these areas, standard normal tables are prepared by the statisticians and available in the appendix of all the books of statistics. So let me consider an examples. Suppose that we want to find out, this is a standard normal distribution with a 0 mean. Suppose this is 1.2, and suppose that we want to determine the area to the left of 1.23, and from the table you will get it as 0.8907 or 89%. From the table you just consult the table of standard normal distribution, you will obtain this as 0.89. And what is its interpretation? The interpretation is that 89% of the observation of the standard normal distribution or the normal distribution is less than 1.23. Now, how to determine area? Suppose this is the standard normal distribution. We want to find out the area to the right of 0.76, this area. Now, the total area under the standard normal distribution is 1. So, to calculate the area to the right of 0.76, we calculate it as 1 minus area to left of 0.76. Area to the left of 0.76 is obtainable from the table. So it is 1 minus 0.7764, that is equal to 0.2236 or 22.36%. That is 22.36% of the observations lie to the right of 0.76. Now suppose that we want to find out the area between say 0 minus 0.68 plus 1.8. We want to find out the shaded area. Now, that is, this can be obtained by area to the left of 1.82, that is 0.9656 minus area to the left of minus 0.68 is 0.2483 is equal to 0.7134, that is 71.34%. So 71.34% lie between these two intervals. It means that 71% of the normally distributed random variable lie between these two areas, because Z is nothing but converted from X. Now we use a notation, that is Z alpha. The Z alpha notation. The notation is that the symbol Z alpha is used to denote Z score that has an area of alpha. The Z alpha notation is used to describe Z score that has an area of alpha to its right. An area of alpha to its right. Z alpha, right, under the standard normal curve. Let me explain what is Z score. Z score is area to the right. So what is meant by Z 0.25? That is 2.5%. So this is Z 0, Z alpha, and the area to the right is Z 0.025, that is this area 0.025, and the value of Z alpha here is, from the table you will get it as 1.96 Z alpha. Z score that has an area to the right of 0.025, and this area is that is the corresponding Z is 1.96. 1.96, this can be obtained by 1 minus area to the right of 1.96. That is 1 minus what is known as 0.025. 1 minus 0.025 is equal to 0.975. That is what to say, to the left 97.5, to the right only 2.5. Then Z 0.05. Z 0.05. The area can be calculated as 1 minus 0.05, that is 95%. 95%, the Z value is 1.645, like that. So Z alpha notation is used to denote Z score that has an area of alpha to the right. What is the Z score corresponding to an area 0.025? Z score, that is 1.96. What is the Z score that has an area of, say, 0.05 to the right? 1.64, like this. 64, like this. So this is how we calculate Z scores, Z values, using the table of standard normal distribution. You can calculate any value to the left, to the right, between any two values. Also you can calculate the Z score. Say 0.025 is 1.96. As an example, is equal to 1.645 as an example, like this.